Hi, 5B. This is the extension task for this week, which is it's the 11th of December today. This is an investigation into different ways of counting. Now, this might sound a little strange, but I think it's interesting and it's worth doing. So, what I thought we'd start with is just start with the way that we normally count. So we're starting with what we call ordinal numbers. So we start at 0. Let me go to 1, 2, 3, 4, 5, 6, 7, 8, 9. Then when we get to 9, something slightly unusual happens. We switch from from 1 digit to 2 digits. And then after that, we go to 11, 12, and so on. I guess the question I wanted to ask is, why don't we have special symbols for like 11, 12, 10, 11, 12, and so on? Why is it that we get to 10, we start using 2 digits? What's so special important about the number 10? I mean, why not have, okay, I've just decided that, okay, that's my symbol for 10. And, that's my symbol for 11. And that's my symbol for 12. Why not? So, and I know that's quite a weird question because we're so used to counting in tens that we don't really think about it. But it's not the only way you can count, actually. I'm going to suggest to you that probably this is the main reason why we count in tens, is that we have 5 fingers on each hand, and that makes 10, and that's that seems like a sort of a common sense place to actually start counting from. But you don't have to. Now, this is like I say, this is probably going to seem a bit weird, but stick with me. What if you were a horse? Well, we count in tens because I say we've got like 10 fingers. What would a horse count in? What might they use for their number system? Well, horses don't have fingers, so I guess they'd have to use their hooves. They'd have to use these, feet, these things they've got at the bottom of their feet. So, what if you could only count using the numbers 1, 0, 1, 2, and 3? Okay, so what I'm going to do here, I'm going to count these, and I'm going to use our normal system. Now, the proper name for that system is called a decimal system because it counts in tens. So I'm going to count these. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, I'm going to count those along the bottom here using our decimal system. And then we'll count them in what I'm going to call horse numbers. There's a proper maths name for it, but we'll get to that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Getting to the edge of the paper and it's going a little wobbly, hold on. 18, 19. Okay, so there's our decimal numbers. Let's count them in horse. So what that means is once we get to, there's no numbers past, no digits past 4. So the first bit would be completely normal. So 1, 2, 3. But what do we do if there's no 4? Well, just like we don't have a special symbol for number 11, we would have to say, if we're counting in groups of 4 here, which we are, then that would have to be 1 lot of 4 and 1 unit. So, sorry, no, I beg your pardon, that would be 1 lot of 4 and no units. And 5 would be, instead of counting as 1 lot of 10 plus 1 unit, we're now counting in 4. So that would be 1 lot of 4 and 1 unit. And 6 would be 1 lot of 4 and 2 units. And 7 would be 1 lot of 4 and 3 units. Now when you get to 8, of course, that is now 2 lots of 4, but we can't call it 14. So that, if 4 in horses would be 10, like 1 whole unit and nothing left over, this would have to be 2 lots of 4 and no units. 19 would be 2 lots of 4 and 1. 20 would be 2 lots of 4 and 2. 11 would be 2 lots of 2, which is 8 and 3 units. 12 would just be 3 lots of 4 and no units. So what we're doing here is we're counting, instead of getting to 10 and starting again, we're getting to 4 and starting again. And the proper name for this, so this is not called horse numbers. The proper name for this in maths is called counting in what's called base 4. All right, so what I'm going to ask you to do, now this sounds a bit weird, but actually humans have done this. The Babylonian number system is actually based on units of, not based on units of 100, it's based on units of 60. Once you get to 59, you have their equivalent of 100, because you've run out of smaller numbers to count with. This is also, by the way, the reason why there is 360 degrees in a circle. That also comes from the Babylonians. Just a link to our angles work. All right. So your task is this. How would insects count? Insects only have 6 legs, so they would probably count in 6s. So how could you count in 6s? And also, there's another one here, which is for, hold on a second, I'll find it. What about spiders? Spiders, they'd count in 8s, wouldn't they? Because they've got 8 legs. Okay, that should be enough to get you started. Have a go. Let me know how you get on. Enjoy.